Alright, hey guys, so what we'll cover today is we'll cover the topic of surds. So surds, you can think of it as like the square root of a number, so such as square root 2, square root 8, and so on. And what we'll get is sometimes we'll get nice surds, so what they'll turn out to be is they'll turn out to be a nice whole number, like square root of 1 is 1, square root of 4 is 2, square root of 3 is, square root of 9 is 3, square root of 16 is 4, and so on. And sometimes we'll get unlucky with it, so we might get something like the square root of 3, which we can't simplify to a nice whole number, will be 1.73, so on, so on, so on. Square root of 2, square root of 5, they will all be irrational, so they'll all turn out to have a lot of decimal places, and it's not nice working with them. So in that case, what we'll go over is we'll go over simplifying surds. So how do we actually make them nice, right? So square root 2 and square root 3, we can't do anything with them. But let's say square root 8, right? What we can do is we can actually simplify surds. And how we simplify surds is we can break square root 8 down into the square root of 4 times 2, which we can break down further into the square root of 4 times the square root of 2, which is square root of 4 we know is just 2 times root 2, which is just 2 root 2. Perfect. So that's our first example. We'll do a couple more examples of surds just to get it, and this is pretty much, you can think of it as the multiplication of surds as well. Let's say the square root of 32. How can we break this down? So we can think of this as the square root of 16 times 2, which is square root 16 times square root 2, which is 4 root 2. Perfect. Good. So that is the beginning of surds. What you can have is typically you find questions like square root 18 times square root of 8. How do we do this? Well, first of all, we can simplify both. So we know this is going to be the square root of 9 times 2 times the square root of 4 times 2. Knowing that, we can simplify this to 3 root 2 times 2 root 2. And what we can do is we can multiply the terms outside the square root, so that becomes 6 square root 2 times square root 2. Square root 2 times square root 2, we know that's just going to be 2, so it's going to be 6 times 2 equals 12. There we go. Perfect. Now, something else, like an interesting property of surds is if you have a square root of 2 and we whole square that 2, that's just going to be equal to 2. So essentially what it is the square root of 2 is equal to 2 to the power of a half, right? So writing it as an index. And if we square the whole thing, what that's going to be equal to is it's going to be equal to 2 a half times 2, which is just equal to 2 to the 1, which is just 2. So that's just another way of proving it. Cool. Now, if you have like something like 3 square root 3 whole squared, remember, we don't just square the surd itself, we have to square the 3 as well. So it's actually 3 squared times root 3 squared, which is equal to 9 times 3, which is equal to 27. Perfect. Good. And just one more, we can have, let's say, 6 square root 2 whole squared, that's equal to 36 times 2. So the 6 squared is 36. Square root of 2 squared is just 2, which gives us 72. Perfect. And that will be our intro to surds.